Morning, guys. Today is our turn to learn about boiling point elevation. Now take a look at this problem. It says, what is the boiling point elevation? I'm going to look for the boiling point elevation of a solution made of 20.1 grams of a non-electrolyte solute and 400 grams of water. So here we can identify a solute. It's unknown, but we know the molar mass. We know the molar mass. 62 grams per mole. Okay. We have solid and we have the solvent. As you can see, the solvent is water. Okay, that's what we can tell about. And let's see, what else do we have? Okay, they're asking me to find boiling point elevation. Boiling point elevation is delta TB. Okay, so the givens in this problem is delta TB. It's unknown, and we know that the solvent is water. Okay, and that's important because of the use of our table that is right here. Okay, I'm gonna place it here. Now, what do we know about water? According to the table, for water, I know that my boiling point of water is 100 Celsius, and my molar boiling point constant is 0.51. So this will be KB equals 0.51. Now remember that unit is Celsius, degrees per molar concentration. Okay, that's what we know about water. Now I'm looking for the boiling point elevation, and in order to look for it, you can see the table of the formula right here. I need KB, which is given, okay, and I need molar concentration, which I don't have. How can I get molar concentration or molality? By dividing number of moles of solute per kilogram solvent. Okay, so from the solvent, what do I know? I know that for the solvent I have 400 grams, and my number of moles of solute, I don't have it. Okay, so that will be my first step. Solution. My first step is to get the number of moles of solute. What do we know about solute? From solute, we know that we have 20.1 grams. Okay? And also, we have the molar mass of the solute, that is 62 grams per mole. So the molar mass is 62 grams per mole. And so in order to get the number of moles, I will do a simple conversion, okay? 20.1 grams times the molar mass as a conversion factor. In order to cancel grams, 62 grams will be below. And in the top, I will have a mole alone. Okay, now I can cancel grams and grams, and I'm gonna have moles. So this will give you 0.32 mole, okay, of solid. Knowing the number of moles, now I can get the molality. That is my second step. Molality, which is equal to number of moles of solid divided by kilogram solvent. I don't have kilogram solvent, I just have grams, but I know that if I divide by 1,000, I'm going to have kilograms. So my number of moles is 0.32 moles divided by 0.4 kilograms. This gives me, let's see, 0.32 divided by 0.4 gives me 0.8. 0.8 mole per kilogram, which is m, okay, molar concentration. Now I have my molality or molar concentration. I have Kb, or the constant of boiling point elevation. So now it is our turn to get what is requested, the boiling point elevation. So this is going to be our third step. It's boiling point elevation, Kb times molar concentration. This is 0.51 Celsius molar times 0.8 molar concentration. Cancel. And this gives me 0.51 times 0.8. This gives me 0.41. So my boiling point elevation is equal to 0.41 Celsius. And voila, that's it for the first exercise. For this second example, we have a solution contains 450 grams of sucrose, and that is the formula for sucrose, of course, and an electrolyte dissolved in 250 grams of water. What is the boiling point of the solution? Now, the problem is asking me to find boiling point, not elevation. It says of the solution, okay? This is what I'm going to focus on. Boiling point of the solution. So, what do we know? We know, okay, the solution is going to be made of what? The solution is made of sucrose plus water. So, sucrose is going to be my solute, and water is going to be the solvent. Now, what do we know about this? Givens. It's time for us to write the givens. They are giving me 450 grams of sucrose, which is my mass of my solute, okay. They are giving me 250 grams of water, which is my solvent, and they're asking me the boiling point of the solution. So boiling point of the solution is unknown. Now, as water is our solvent, we know that the boiling point of water is 100 Celsius degrees, and Kb, or the constant of boiling point, well, it was lowercase b, sorry, 0.51 Celsius per molar concentration. So, what do I need? So, according to the formula that we have, to calculate the boiling point of the solution, I need boiling point of the solvent plus boiling point depression. That means that I need to calculate my boiling point elevation first, okay, which is here, boiling point elevation, Kb times molar concentration. I don't have my molar concentration, okay? I don't have this. So this is going to be our first step. First step is molar concentration. It's number of moles of solute per kilogram solvent. I don't know my number of moles. So I'm going to calculate the number of moles first. How? Because they are giving me 450 grams of sucrose. Okay? So I'm going to multiply this times the molar mass. Okay. Sucrose, let's see. Let's calculate the molar mass. 12 times 12 plus 22 plus 11 times 16. This molar mass gives me 342 grams per mole. This is the conversion factor that I will use, 342 grams per 1 mole. Okay, now I can cancel the units and I will perform that division. 450 divided by 342. This gives me 1.32, okay, moles. 1.32 moles of sucrose, which is my solute. In my second step, with the number of moles, I will get my molality, okay? Molality will be number of moles per kilogram solvent. My number of moles is what I just got, 1.32 mole divided by kilogram solvent is 250 grams into kilograms is 0.25 kilograms. This gives me 5.28 m. Okay, now you have your concentration. Now we can get the boiling point elevation. Okay, so let's see. Delta TB equals Kb times molar concentration. Kb, which is 0.51 Celsius over molal times molal, which is 5.28 molal. So my it's not depression, my elevation is going to be 0.51 times 5.28, 2.69 degrees Celsius. But this is not what the problem is asking me to find. It's asking me to find boiling point of the solution, so that will be my last step. My fourth step will be boiling point of the solution equals boiling point of the solvent plus the boiling point elevation. So this is going to be my solvent, which is water, has 100 Celsius as a boiling point, plus the elevation. If you remember, the equation used to be negative, but now in elevation we're going to have positive numbers. So this will be 2.69 degrees Celsius. So my boiling point of the solution is going to be equal to 102.69 degrees Celsius. And this will be my final answer for this problem. Now for this problem it says, if the boiling point elevation of an aqueous solution containing a non-volatile electrolyte is 1.02 Celsius, what is the molality of the solution? So they are asking me something different this time. They're asking me to find what is the molality of the solution. This is going to be our unknown this time. So let's write the given Okay, they are giving me boiling point elevation. If the boiling point elevation, so this is delta TV. Delta TV, it's 1.02 Celsius. They are giving me an aqueous solution. Aqueous means water, okay? It's a solution in water. So that means that the solvent here is water. And they're asking me to find M, which is unknown. But we do know a few things about water. Water, it has a boiling point to be 100 Celsius. Boiling point of H2O is 100 Celsius. And the constant Kb is 0.51 Celsius per mole. Okay. Now let's take a look. In order to calculate molality, we can use two formulas. The regular equation for molality that involves moles of solute and kilograms solvent, but as you can see, none of this is given, okay? They're not giving me any mass at all, okay? But the other way to calculate molar concentration is by isolating from the boiling point elevation. So this is molality, and it relates elevation divided by the constant. We have elevation? Yes. We have the constant? Yes. Just apply the formula. This is like the easiest example. One single step, and you have molar concentration equals elevation divided by constant. The elevation is given 1.02 Celsius divided by the constant, that is 0.51 Celsius per molar concentration. Remember to cancel the units that are equal and opposite. 1.02 divided by 0.51 gives me exactly 2. So that means that my molar concentration for this solution is 2. The unit is m. Okay? Molar concentration or molality equals 2m. And this is the answer for this problem. Thank you.